When plastic, water, or gas lines are installed in residential construction, the National Electrical Code requires that any copper stub-outs, such as those used for faucets, that are 18 inches or longer must be bonded with a number 6 wire. This requirement exists because plastic pipes are non-conductive and cannot serve as a grounding path for electrical faults. The purpose of bonding is to create a low impedance path for fault current to return to the source, which facilitates the operation of overcurrent protective devices like circuit breakers or fuses, thereby minimizing the risk of electrical shock. The number 6 wire provides the necessary low resistance path to ground. This grounding path is crucial because if a live wire were to come into contact with a copper water pipe without proper bonding, the pipe could become energized. Anyone touching the energized pipe and a grounded object would be exposed to a potentially lethal electrical shock. By bonding the copper stub out to the grounding system, a fault current would flow through the number 6 wire back to the electrical panel, causing the circuit breaker to trip and energize the circuit. The specific requirements for bonding are detailed in Article 250 of the National Electrical Code, which covers grounding and bonding. It is very important to consult the latest edition of the NEC for the most up-to-date regulations and interpretations. The NEC specifies the methods for achieving effective grounding and bonding. Several factors influence the effectiveness of a grounding and bonding system. Firstly, the size of the grounding conductor, which in this case is the number 6 wire, must be adequate to handle the potential fault current. The NEC provides tables that specify the minimum size of grounding conductors based on the size of the overcurrent protection device. Secondly, the connections must be made properly. The connection should be tight, corrosion resistant, and made with listed connectors. Thirdly, the path to ground must be continuous and have low impedance. This means that all connections in the grounding path must be secure and free of corrosion. The grounding electrode system serves as the reference point for the entire electrical system. This system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal and groundwater pipes that are in direct contact with the earth for at least 10 feet. The grounding electrode system provides a stable reference point for the electrical system and helps to dissipate fault current into the earth. To properly bond the copper stub-out, the number 6 wire should be connected to the stub-out using a listed bonding clamp or lug. The other end of the number 6 wire should be connected to the grounding electrode system, typically at the main electrical panel. The connection at the panel should also be made with a listed connector. It is crucial to ensure that all connections are tight and secure to maintain a low impedance path. It is also important to protect the bonding wire from physical damage. The wire should be run in a manner that minimizes the risk of it being cut, kinked, or otherwise damaged. If the wire is exposed to physical damage, it should be protected by conduit or other means. In addition to bonding copper stub-outs, it is also important to bond any other metallic piping systems that may be present in the building. This includes gas piping, heating piping, and other metallic piping systems. The purpose of bonding these systems is to ensure that they are all at the same electrical potential, which reduces the risk of electrical shock. The NEC provides specific requirements for bonding these systems. It is important to consult the NEC for the most up-to-date regulations. In addition to the NEC requirements, local codes may also have specific requirements for bonding. It is important to check with the local electrical inspector to determine if there are any additional requirements that must be followed. Proper bonding is essential for electrical safety. It helps to protect against electrical shock and fire hazards. By following the NEC requirements and local codes, you can ensure that the electrical system is properly grounded and bonded. The NEC is updated every 3 years, so it is important to stay current with the latest edition. Changes and revisions are made to address new technologies, safety concerns, and evolving industry practices. The electrical inspectors play a critical role in enforcing the NEC and ensuring that electrical installations are safe and compliant. They review electrical plans, inspect installations, and provide guidance on code requirements. It is important to work closely with the electrical inspector to ensure that the electrical system meets all applicable codes and regulations. Bonding is not only a safety measure but also helps to reduce electromagnetic interference, or EMI, which can affect sensitive electronic equipment. Proper grounding and bonding practices minimize noise and interference on electrical circuits, leading to more reliable operation of electronic devices. When dealing with electrical systems, it is essential to follow safe work practices. Always de-energize circuits before working on them, and use appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses. If you are not qualified to work on electrical systems, hire a licensed electrician. Licensed electricians have the training and experience to safely and effectively install, repair, and maintain electrical systems. They are also familiar with the NEC and local codes. The proper installation of a grounding and bonding system is crucial for the safety of occupants and the protection of property. A well-designed and installed system provides a low impedance path for fault current, which helps to prevent electrical shock and fire hazards. Remember that electrical work can be dangerous if not performed correctly. If you are not comfortable working on electrical systems, it is always best to hire a qualified electrician. Bonding and grounding are fundamental concepts in electrical engineering and safety. Understanding the principles behind these practices is essential for anyone working with electrical systems. Firstly, grounding provides a reference point for the electrical system, ensuring that all conductive surfaces are at or near ground potential. Secondly, bonding connects conductive parts together to create a low impedance path for fault current, allowing overcurrent protective devices to operate quickly and safely. The combination of grounding and bonding provides a comprehensive approach to electrical safety. The number 6 wire requirement for bonding copper stub outs is a specific application of these principles. By understanding the reasoning behind this requirement, you can better appreciate the importance of proper grounding and bonding practices. The NEC is a comprehensive document that covers a wide range of electrical topics. It is essential to have a thorough understanding of the NEC to ensure that electrical installations are safe and compliant. The NEC is not a design manual, but it provides the minimum requirements for electrical safety. It is important to go beyond the minimum requirements to ensure that the electrical system is properly designed and installed. In addition to the NEC, there are other standards and guidelines that may be applicable to electrical installations. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. It is important to be aware of these other standards and guidelines and to follow them when applicable. Electrical safety is a shared responsibility. Everyone who works with electrical systems has a responsibility to ensure that the work is performed safely and in accordance with applicable codes and standards. By following safe work practices and staying current with the latest codes and standards, you can help to prevent electrical accidents and injuries. The bonding of metallic water piping systems is an important safety measure that helps to prevent electrical shock hazards. When a metallic water pipe comes into contact with a live electrical wire, the pipe can become energized. If a person then touches the energized pipe while also in contact with a grounded object, such as a metal appliance or a damp floor, they can receive a dangerous electrical shock. Bonding the water piping system to the electrical grounding system provides a low impedance path for the fault current to flow back to the source. This causes the circuit breaker to trip, cutting off the power to the circuits and preventing the electrical shock. The number 6 wire is the minimum size wire required for bonding most water piping systems in residential applications. The actual size of the bonding wire may need to be larger depending on the size of the electrical service and the length of the piping system. It is important to consult the NEC and local codes to determine the correct size of the bonding wire for a particular application. The bonding wire should be connected to the water pipe using a listed bonding clamp or lug. The connection should be made as close as possible to the point where the water pipe enters the building. The other end of the bonding wire should be connected to the electrical grounding system at the main electrical panel. It is important to ensure that all connections are tight and secure to provide a reliable low impedance path. In addition to bonding the water piping system, it is also important to bond other metallic systems in the building, such as gas piping, heating ducts, and metal building components. The purpose of bonding these systems is to ensure that they are all at the same electrical potential, which reduces the risk of electrical shock hazard. Proper bonding and grounding are essential for electrical safety. By following the NEC and local codes, you can help to protect yourself and others from electrical shock hazards. Always consult with a qualified electrician if you have any questions or concerns about electrical safety. Firstly, the NEC section 250.104 covers bonding of metal water piping. Secondly, it states that metal water piping systems that are likely to become energized shall be bonded to the service equipment grounding electrode conductor. Thirdly, the bonding jumper shall be sized in accordance with table 250.102 C1, but shall not be smaller than number 6 copper or number 4 aluminum. This means that the number 6 wire is the minimum size wire that can be used for bonding most water piping systems in residential applications. The NEC is a complex document, so it is important to consult with a qualified electrician to ensure that all electrical work is performed safely and in accordance with code. Remember that electrical safety is a shared responsibility, and everyone has a role to play in preventing electrical accident. Always use caution when working with electricity, and never attempt to perform electrical work if you are not qualified. The grounding electrode system is a critical component of the electrical system, providing a path for fault current to return to the source and helping to protect against electrical shock. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal underground water pipes. The grounding electrode system should be installed in accordance with the NEC and local codes. The grounding electrode conductor connects the grounding electrode system to the service equipment. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. The grounding electrode conductor should be installed in a manner that protects it from physical damage. The equipment grounding conductor provides a path for fault current to return to the source from electrical equipment. The equipment grounding conductor is typically a wire that is run with the circuit conductors. The size of the equipment grounding conductor is determined by the size of the overcurrent protection device protecting the circuit. The equipment grounding conductor should be connected to the metal enclosure of the equipment. The combination of the grounding electrode system, the grounding electrode conductor, and the equipment grounding conductor provides a comprehensive grounding system that helps to protect against electrical shock and fire hazards. Always consult with a qualified electrician if you have any questions or concerns about electrical grounding. The information provided here is for general informational purposes only and should not be considered as a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work. Bonding and grounding are essential for electrical safety. By following the NEC and local codes, you can help to protect yourself and others from electrical shock hazards. Remember that electrical safety is a shared responsibility, and everyone has a role to play in preventing electrical accidents. Always use caution when working with electricity, and never attempt to perform electrical work if you are not qualified.